And with that, I think that we can go ahead and dive into the first topic. So we will hand it over to Mohammed to lead the discussion and get us started. Take it away, Mohammed.
We're going to get started about talking about hardware automation. So we have up here, Kendall just shared their screen. It keeps flopping back and forth, but hopefully we'll get the screen spotlighted, and we'll have the screen shared in front of everyone. So if you're looking to actually participate in the conversation and on the Etherpad, I suggest opening the link that we posted earlier in chat. And I guess we can share that again as well. Otherwise, if you're just looking to follow the conversation, you can also do that by having the Etherpad open in front of you. I'd really like to ask everyone who's here to fill in their information, just so that we know who's actually in here today. And don't worry, we're not selling this. No one's going to contact you to buy some hardware automation software after this. The other thing is, please put in a little star next to your name if you're interested in participating in the conversation. It'll be really nice and helpful to have more input because this is a conversation and a discussion. It's not really a one-way kind of panel. So the more people that we have involved, I think the more productive this entire conversation will be overall. So to start off, our first topic is pretty much end-to-end hardware provisioning lifecycle for bare metal. So to kind of give a brief introduction for this subject, we all, there's a whole process that we have from going from the day you decide to buy some hardware until the day that it's running your production applications. And so that there's a whole set of things that happen inside all of that workflow. And I think that there's a lot that all the different individuals that are running data centers at different scales have different experiences that they could share together about how we can do this more efficiently. And so I have jotted down a few interesting subjects to kind of start and spark up the conversation. And I guess the first one that I had, which is something that's common and probably shared across all of the different users, regardless of your scale, is having a system to manage, your data center infrastructure management, your assets, your IP addresses, configuration management, all that other stuff. So I wanted to start off and maybe ask if someone is interested in sharing on, how they go about dealing with this inside their organization, and what are maybe some of the things that they wish they could, do better, or some of the things they like about the way that they do it, and maybe just to share how you currently do this inside your environment. Usually we need one person to start volunteering, and then we'll get the conversation going. So
I could.
Sorry, I was gonna say, we could also flip the question on its head a little bit, and if you have not done any of these things and you're still using spreadsheets, why not? Why have you not looked at automation? Because that's a really good piece of information for everyone to take away to understand what is preventing it and what we could possibly do to improve things or make it easier to consume or easier to adopt.
Yeah. James, you want to share something?
Sure, yeah, I can kind of kick off with just talking a little bit about how our stuff works at Verizon Media. Because there's like a lot here, so I could ramble for hours on just how our stuff works. So I'll try and keep it brief, but we have an operational asset database. So all assets deployed in the data center go into that database. And right now, there are some, there is some automation there. It's not automated to the degree that we would want to see that happen. So when all hardware enters our facilities, we actually have our on-site personnel or site ops personnel. They actually have little hand scanners now, so they can go through and they can scan the asset tags. We work with our vendors to put asset tags on the cabinets for us. And so our site ops people can go through and scan those asset tags, and that actually associates it with the MAC address and all the other information that was sent to us previously by the vendor. So cabinets come in, already have asset tags on them. We've already received digitally some form of information about like all the MAC addresses that we're going to see in that cabinet, as well as all the asset tags. So when our site ops people go and they scan that, they know, okay, this is rack number whatever. And as they scan each host, it actually starts going and updating that operational asset database. Sort of. There's a couple extra manual steps in there. This is a pretty imperfect process because different vendors put different stickers in different places. So like some have a little thing you can pull out and the sticker, like the MAC address barcode will be on that. But it all depends on who built the machine that day. So we have some where that little pull-out thing doesn't have anything on it, and they went and put the MAC address sticker underneath the lid of the machine. So when that happens, we have to pull out the machine, flip up the lid, find the sticker. You know, it could be on the side, it could be on the top, it could be inside the box, it could be anywhere. But so they go through, they scan that, it all goes into the asset database. And then from there, there's this other long chain of events that kick off in terms of, you know, the network team provisioning the switch, making sure that's configured correctly. The same asset database has a separate set of tables for subnet and supernet information globally. There's an entire different network management system just for provisioning those subnets and pushing them out to switches. Configuration management is like yet another thing. So all of these things exist kind of in separate pieces for us. And then there's some other orchestration tooling that sits on top of them, sort of stitches that data together. It definitely all works fairly well. And actually that asset database acts as the source of truth for Ironic. So for us, hardware comes into the data center, it gets scanned, it then goes through a series of tests. Our site ops people run a script that goes and it tests the hardware and makes sure that all the information we need in the asset database is there. They make sure that they can boot the thing. And then once it's done, it gets sent over to Ironic. And so then we have a script that then takes it into Ironic, runs it through, well, what we call cleaning. We backported cleaning into the version of Ironic we have, which is basically we just install a version of Linux on there. And once that's all said and done, it's up and it's ready to go and it's ready for someone to use. And then we handle quota provisioning is basically as a separate problem.
Mm-hmm. So that's really interesting. So James, so it sounds like, you know, you and your team operate at a rack level scale. Not a single server doesn't show up to your, most of the time what it sounds like. You get a whole rack of servers right off the bat.
Yeah, it's usually cabinets at a time, but we do also have hardware that we call just sort of loose, which is if a team just needs like 1 or 2 machines or something like that, then or really if they're replacing a machine, then our setups people will go and just install a single server into a rack somewhere. But whenever possible, they tend to do entire cabinet builds.
Yeah. So then I want to take that, and I think that's a really interesting process that you shared with us. But I wonder if there's someone here that works maybe at a scale where they work, let's say, on a machine scale, or for example, they get a pallet of servers and not a full pre-set up rack, and maybe someone can share how they work with on a more individual server basis. You know, is there any workflows that you find kind of interesting about what James had kind of proposed, or any differences in maybe how you would do something like this?
So I can speak from my past in data center operations, and basically what James was talking about was kind of like the holy grail of site ops, and being able to go barcode scan the machines and know that they're there and be able to assert that, because when you start dealing with those things, you also kind of have to deal with capital asset inventory as well, and reporting that and paying taxes on that equipment too, at least if you're in the United States. So all that would have been great 10 years ago for me, and it would have made my life so much easier. Unfortunately, I don't have a time machine.
Yeah, cool. Okay, so go ahead, James.
I was going to say, you know, something we have, we also have like on-site factories for doing cabinet integrations, which is when we actually are getting pallets of gear and assembling. And I was wondering if anyone else kind of did that, if they had sort of like an on-site factory, or what they call a factory, right, where they're integrating cabinets themselves. If they have, it'd be cool to hear like what you're saying about if anyone just has a current process they're doing that they're willing to share.
Yeah. So to chime in on my side, we usually have cabinets already in the data centers. And so we don't necessarily bring the cabinets directly, but we work with system integrators that kind of ship systems that are all kind of pre-integrated, and then we kind of just rack and stack everything inside these data centers. And obviously there's nice things and there's, you know, not ideal things in doing this. And so when we're doing something like this, the nice thing is we work with a solid integrator that does help and bring a lot of what you mentioned earlier, which is we can get a digital record of everything that's coming in with all the MAC addresses and all the information, which is really tremendous help. I suggest anyone that kind of works with acquiring hardware to work with your vendor and just say, hey, can I have this ahead of time? It's really useful because, you know, spending an hour trying to figure out why this machine won't boot and it's because someone made a typo in the MAC address, or nowadays, what's interesting is if you have an integrator that's based out of California, they, I think, recently passed a law where they're not allowed to have kind of like, they need to have secure by default values. And so now we no longer have like admin, root Calvin. They actually have to ship servers out with randomized passwords. And I think that brings another challenge because now you have like another step of actually needing to have all those credentials. And, you know, usually they're like on a sticker somewhere on the machine, but, you know, you really want those in a digital record so you can go and enroll these into whatever system that you need to use. And sharing passwords is, you know, copying those over when you're getting, you know, hundreds of machines isn't exactly what you want to be doing. I noticed also, I see some people from China Mobile, and I think it'd be really interesting to hear maybe some of the process there, because obviously, you know, you work at such a big scale over there, and it'd be really interesting to hear sort of your use cases or how that all works in your scope there. I don't know if we have them here on the call.
Hello, Mohammed.
Yes, hi.
Yes, my name is Xiao Guang. I come from China Mobile. Now, because I give some use case about China Mobile's NFV network cloud. In our NFV network cloud, about 50,000 servers involved in this project. So the major problem for us is about the hardware integration, because the huge scale. So it's hard for us to do some manually work as traditional. So we have to do some automation integration work to fix the problems. So we build the automation process. The first, after we order the hardware machine from the vendors, then we will do some things parallelly. For example, we will do some pre-configuration about hardware. For example, the servers, the switches. We ask our vendors do some pre-configuration according to our hypervisor needs or some automation tools needs. At the same time, we will do some pre-verification in our lab. Of course, at the same time, because as we know, the automation tool based on the standard data, so we will have to build the low-level design standard data at the same time. Of course, when the hardware shipped to the site, they will do some on-site work. After all this work, we will enter into the automation process. First, we will do some automation configuration, include the servers, networks devices. After that, we will do some verification test about the hardware. include the server configuration, switch configuration, and the cable connectivity. After all this works, we will output the verification report. If there are some errors during the above processes, the on-site engineer will do some correction about all the work. So because we have our automation tools, it's the efficiency and the quality is improved significantly. This is the total process for our for China Mobile's practice. Thank you.
That's cool. So I have some, so what you're bringing up is really interesting because I wrote a little bit on that on line 92, and it was about working with vendors and pre-validating servers. And we also got a question on that in the chat. So maybe I want to ask you while you're still here is how much validation do you ask your vendors to do beforehand? Do you ask them to say, like, if you use a specific version of Linux, do they have to install it and validate it before they send it to you? Do they run and burn-in tests? What's the usual interaction with kind of China Mobile and the vendors they buy hardware from?
Before we buy, as you know, we have before we buy the hardwares, we will have some tender files to ask vendors to provide the hardware which will meet our requirements. For example, we ask them to provide the specific hardwares about the some specification. For example, the CPU, RAM, disk, network card, such kind of certain kind of components. We also this is hardware configuration. I will also ask them to provide some software configuration. For example, the BIOS configuration. For example, the NUMA enable, VTX, the power policy and the performance policy, such kind of configuration. Of course, as you know, we will use the automation tool to do some automation work in the next step. So we have to ask our vendors to do some configuration about the automation. For example, we ask them to enable the BMC port LLDP protocol, and we also ask them to enable the DHCP client for their switch management port, such kind of configuration for our automation tools. So this is some rules for vendors' children.
That's interesting. And then, so that's really helpful. Maybe James, I want to maybe redirect the question also to you about that we got in the chat, which is requiring vendors to pre-validate servers for specific configs. Do you want to chime in on that? And I can do after as well.
Yeah, we do have some things like so. We have some agreements with vendors where we ask them to set like BIOS, certain BIOS settings, specifically like make sure that the machines are PXE bootable, just so that we can do something with them as soon as they come into the data center. And so that's one of the things that we ask that they do. There might be some others, but I'm not informed as to what those are. But if there's an opportunity, I'll ask some of the folks at work and see if there's anything they can share. But I know at least we do ask they set certain BIOS settings for us and do some kind of hardware validation. Otherwise, everything happens once the gear comes in. We go through and revalidate everything once it comes into the data center.
Maybe I can just give an example of what I meant here, because we do. So this is Anna from CERN. So we have something very similar when we buy hardware. We also ask the vendor to set specific BIOS settings and so on. But we had cases recently where, for instance, we realized only when we hand over the node to users that, for instance, a driver is missing for, I don't know, I think it was an NVMe device, or it was unclear how to do certain UEFI RAID configurations and boot from these. So I was just wondering if people hit something very similar, because in some cases we only find out when we hand out the hardware to the users, and it would be nice if we have this up front. For instance, have like CentOS 7 validated, CentOS 8 validated, Windows validated, and so on, and like the vendor does that. I was just wondering if people do something like this, or if they like hardware comes and then the validation starts on site.
Yeah. So actually, so when we go to buy a new like platform of hardware, we have a performance engineering team that works closely with all of our vendors. And let's say that we're going to buy a new hardware configuration from vendor Foo. They'll first get an evaluation machine shipped in. And then they take that machine and they put it in the local performance testing lab. And so I think there's some things that happen ahead of time where we try and make sure that, like, yes, it's going to have these hardware platforms, or these drivers or whatever that are known to work. But then they still go and get at least one evaluation machine, and they actually set it up in a lab on site, and they do a number of tests on it. So they fire it up, they make sure they can image it, and they go through, they run it through like a little test life cycle a few times. They make sure they get an operating system on it. They see, does it actually work? Does it work with our disk image? With our RAM disk environment that we have set up in Ironic. That's something they've just started doing for us.
Right. Now, this sounds very similar to what we do. So our team that actually does the procurement of the hardware does something very similar. They get test machines up front, but then there's a little disconnection between the people taking care of the hardware and buying the hardware, and then it goes through for Ironic in our case as well, and then goes to the user, and there's kind of and the Linux team is in between as well. So there's a kind of a slight disconnection between the end user and the ones buying the hardware. So this is one of the problems.
Maybe I can
literally the same case for us.
I can also jump in. Hopefully you can hear me.
We can.
Yeah, thanks a lot. So I'm Umar from Schwarz IT, and maybe what Arne is mentioning is hit homes closer to me, because we usually don't get new hardware. We get hardware which was used already, and then there are many things that we need to configure ourselves, and there's no luxury of telling a vendor to do it already for us. So I completely agree. There's a disconnect where maybe I have to set the Pixie boot or set it to default, because someone who is installing the hardware for me doesn't care about it. So I think there is this gap where making sure that the server is ready for me, I have to go there physically. And that's also quite an important point where I wanted to know what other people do. So I'll just explain it a little bit more. So someone has used the server before. They have maybe manually installed something on it. Maybe they haven't the DHCP enabled for the ILO or for the iDRAC for Dell, for example. And then there's no automated way of going there and resetting it. You have to do it manually. Yeah, so that's a gap which I think cannot be filled yet, but whatever I have studied.
So if the Ironic does provide you the way to first of all reset everything to the let's say factory one, and then configure it to the way you want it to, including which NICs to be used for Pixie booting, RAID, BIOS settings, the whole 9 yards. Does that satisfy the requirement, or there is some additional thing which need to be done?
For example, if the ILO hasn't been set to Pixie boot, how can you add it to Ironic? So you need some information before getting it to Ironic, and that information is not there. So the bootstrap has to be done manually yet.
Well, the driver itself have that, but Ironic does not have the top level command to expose it yet.
So I think the Arkady, I think what Umar's trying to explain here is it's kind of like you can't have Ironic manage it if you haven't done the initial bootstrap on the physical machine to set it up on DHCP or Pixie Boot. And if it has some arbitrary IP address on its BMC that is not reachable by Ironic. So
Yep.
I think what they mean
The
here is you
reachability-
have to go through that.
Yep. So I mean, there is a minimal requirement, which is reachability, and you have to have the credentials.
Yeah.
Ironic support two mode of operation. One is in band, one is out of band. For out of band, you don't need any Pixie booting setup at all.
Correct.
And you can extract all of the data you want to, and you can configure it you want to, including the Pixie booting itself. So, I mean, yes, there is additional step need to be done in order to be able to set up the Pixie booting, but you can, it's possible to do it out of band. So
well, I think what they're also trying to say is that the case that they're running into is there is no configured network or enabled networking for the BMC at present. So they're having to go through that step and or make those settings changes. And that really is going to require physical access right now.
So absolutely, this is why I put out the question. I mean, what is the minimal requirement, for the setup required in order to do something? Which is obviously if you don't have a network connectivity to the device on the server through which you can configure things, and there's not much you can do. But assuming that you have some connectivity to either ILO or IDROC, or whatever is equivalent on other nodes type of the hardware, then that's possible, and including setting up the Pixie and all of the other things. And there are support for assigning the IP addresses to those through the DHCP. So simplify things. I don't know if for different environment people might not want to have dynamic IP address assignment, would like to have a static one. I mean, that's understandable. So trying to understand what is a bare minimal as a starting point was kind of the question for me.
Yeah, I agree with that. I think that's kind of that's the hardest part in all the operations, and that's mainly why we're here today. Is everything is nice and automated, but that's the only part that we need to minimize. And I think Omar raises kind of an interesting point of it's not always the case that you get hardware that's in a perfect world coming in with all the MAC addresses and all the information you need. I've seen stories that were shared with someone getting a shipment of a large number of servers that accidentally forgot to set up DHCP on all of those, and they all came with like the 192, 168, 1.120. So that required someone to go just in one by one and fix up all those servers, and obviously that is a very long and painful process. Also, I want to share my side a little bit on the question that was raised earlier on validating the hardware. So to us, it's been very interesting because of our focus on using open source software. A lot of the vendors, unfortunately, don't necessarily validate for Linux distributions that are free software, aka Debian. A lot of times there'll be like Ubuntu certifications, and there'll be RHEL certifications, which indirectly gives you CentOS. And even those can be tricky sometimes because you got to trick their like little software validation tools that you're actually running CentOS, and it's okay to not don't blow up because it's saying CentOS and not Red Hat. But so that's been a struggle for us because a lot of times the vendors kind of just don't really have interest in doing that, and a lot of it falls on the community. And so there's a really strong, obviously, community to get on to help deal with these issues. But a lot of times what we end up doing is rolling out our own kernel and to get the newer drivers that fix some of the issues that are underlying in these machines, which is not ideal, but it's kind of part of what we have to do. And then the other thing is, like James also mentioned, is we work based on platforms. So, we start with one system and test out all the different use cases. And then once that's the case, we just keep reusing that same system for every single iteration of it. We have different flavors of the same systems. So once we have a specific platform, and it's validated. Some might have more memory, some might have less memory, depending on the use case that we're using it for. But overall, the things that need to interact together, where it's the networking cards and the drivers for those and the motherboard and all these different things, they all kind of stick the same, which makes it a lot easier to manage. Which now brings up another kind of interesting thing that we're discussing is environments with multiple flavors of hardware. So it's one thing to have multiple flavors that are running different memory and disk and requirements, but it's another problem to have a bunch of vendor A, vendor B, vendor C hardware. And how do you monitor all that? So I wanted to maybe jump back a tiny little bit and ask, how does everyone do things like monitoring? And what I mean by monitoring, I mean hardware platform monitoring. Like I think, Dell has their serve admin stuff, and HP has their own thing, and then Supermicro relies on IPMI. Do you set a lot of standard and stick to that standard for all your machines? Do you pick hardware specific things? I want to maybe open up and hear what everyone has to say from that. Well,
maybe I can start.
Sure.
For HP, and this is very preliminary. I don't know if that is standard practice or if this is even a good thing to do, or if there's better ways to do. But for HP, if you go to ILO, you get some health reports, and you can use the API to, I don't know, collect them or display them on a dashboard, for example. So if a disk is failing or some RAM slot is not accessible by the processor, you get that information. And then, for example, you can have a dashboard where all the servers that you are having are listed with their health status. So from the ILO, you can directly get this information using, I think, the Redfish API. They have different versions for different ILO 4, ILO 5, I think. And for Dell, I'm not sure because I haven't done it yet, but I think you can also get directly from the iDRAC. So that is the method that I know of, and I would be really interested to see how people do it for themselves.
Let me share some practice from China Mobile. We use hello. We use Redfish to do some management work or some monitor work, because now we both for servers, we all need the vendors support the Redfish interface. Use them to do some server management, assert management, and some monitoring and some alarm work. Now we use because we meet a problem is how to how about our enterprise requirements and the community, open community, the Redfish community version. So now I have some experience to share with you is that we we set up our requirements based on one Redfish version. But as you know, the community's Redfish version is increasing. It's hard for us to catch up. So our policy is that we will use one version, and if our enterprise have some customized requirements, we will add it into the specification. But at this time, we will first check the community's version. If they have this feature, we will add the feature into our requirements. If not, we will add some requirements as we need it. That's so we use this method to help us to keep to keep the same step with the community. At the same time, we also meet our requirements.
Mhm.
Okay.
Cool. And so do you use Redfish as a standard way to interact with all of your systems at this point, or you still have a little bit more work before you can use Redfish everywhere?
No, because as you know, in the NFV cloud, we use Vim and PIM to manage all our hardwares. So now we for servers, we ask them to provide the Redfish interface. But for other devices, for example, some old devices, especially for some network devices, they still have some SNMP, such kind of interface. So maybe we will management different devices according to different policy.
Okay. And I guess you have multiple monitoring systems, some monitoring that watches Redfish and other monitorings that watch SNMP or something like that?
Okay, but in fact, this is a big challenge or problem for our OSS systems to do some management and monitoring. But now gradually we will do some unified work to use a unified platform to do all of this work. We will try our best to do some standard work.
That's cool. That's a really interesting perspective to hear from your side. I'll share a little bit on what we do here, because we do have an interesting use case, because we actually manage hardware all over the world. And the other challenge is sometimes that hardware is not necessarily ours. So we don't actually always have a say in getting access to Redfish API or something like that. And the way that we've gone about this, so we actually run a Kubernetes control plane every single location that we run. And we built a tiny little tool called Node Labeler, which is an open source project. It's really interesting. It's a small Golang project. And it's crazy how even the small world is. I was looking for a library that extracted information out of the hardware and gave us, what is the manufacturer, what is the make, the serial number, and things like this, because it was really hard to manually add that information and label the nodes in Kubernetes. And I found a library, and the library was actually written by someone, Jay Pipes, who actually happens to be involved in the OpenStack community for years ago. So it was really interesting to have that circle around. But we wrote this little thing that we run as a daemon set across all of the nodes that we run. And what it does is automatically poll the system and check what is the make, model, serial number, all that information, and labels the node on that. And so what that allows us to do is it allows us to run certain Prometheus exporters on those machines, and we use the selector as the make and model of that specific machine. So for example, there's a Dell hardware exporter that allows you to get all the hardware information from a Dell machine, and that's just an open source project. And so for example, on all of the clouds that we run, we just run that hardware exporter as a daemon set, and we set it up as a node selector, so it only matches Dell hardware. So it only gets and retrieves stuff from Dell systems. And then we kind of do the same for like HP systems, and then anything else gets IPMI. So that's one interesting approach that we took. And that's mainly like trying to make the best out of all the different choices. I don't know if anyone has any questions or curious about how we do this. I can talk a little bit more in depth about it.
I'm really excited to know, is the Dell Prometheus exporter an open source thing that you can run anywhere, or does it come with some support package or something?
Yeah, so it's an open source project. I'm not the one behind it. I just happened to be one of the users. I'm going to post it in the Etherpad here. Grab it. I just Googled it up. So going to be on line 139 is the hardware exporter. And so we run that. We run the Docker image, this ship there. And then if you also want to have a look for the node labeler that we run, I mean, you could probably, well, it's really meant for running inside Kubernetes, but if that is something that interests you, it's also set up here. So you can do that. And I think we have a Helm chart for that somewhere. So that's something that could be interesting if you're using Kubernetes for bare metal and whatnot. Cool. I guess we're mostly halfway through the discussion. I wanted to touch on one last subject before maybe switching it to the BIOS and firmware automation. And I guess the question is going from one data center to N data centers. And I'm wondering if anyone kind of would like to share their experiences, because I think whenever you start building out your first rack and you grow into a second rack and you're growing more, you're not really thinking about way down the line. And this is on line 145. You're not thinking on way down the line when you're going to have two data centers. And then all of a sudden you've got to decide what your network segments are going to look like, and are you going to have how your VLANs are going to look like, and are you going to interconnect those data centers, and what do you do about all that? So has anyone maybe recently gone through something like this that they'd like to maybe share a little bit about their experience in going from one to multiple, or how do you deal with multiple data centers? I know I saw unmuted from China Mobile. I'd love to hear how how you're doing, because I know it's at a very large scale, that's for sure. Okay, I don't think we can hear you. Yeah, it's cutting off a lot. I just heard a blip of noise. Fortunately, technology isn't perfect. And that's why we're here.
So Prakash here, I can chime in a bit.
Yeah, sure.
So the biggest problem one faces is if you design one data center and then suddenly you did not plan for the second data center and it comes up, first thing comes to mind is, oh, should I, example in OpenStack, do I have a federated or do
I wonder if we lost Prakash.
Yeah, I was worried that it was my internet that's acting up, but
Yeah.
I
can.
Internet.
Oh, no.
Go ahead.
So,
are you able to hear me?
yes, we can.
Yes, we can hear you again now.
So the second challenge comes is once you have a mix-up between the Kubernetes being part of it, and so you have container workloads as well as bare metal and VM workloads. So the challenge comes to which one do I use? Do I use the Keystone as the main provider and have external authentication, or do I look at go to Keystone and modify all those external versus federated, and then there is a conflict or something? So not only that, this is only on the authentication triplet side of it. The other side of it, if I am asked that, hey, I need to have a OpenEDX installed for educational segment because we have got hundreds of data centers. Now what do I do? So the API of the application, the authentication are the key associated with that. So that is one part of it. The other part of it is from the networking side. I'm forced to decide how do I do networking. Is it provider networking, or am I just going to use a router and do a BGP and externalize? So many thoughts and multi-site, we need to think top down whereas you are stuck in a data center which you designed without thinking that. That's the major challenge we face. So it is networking issue, it's authentication issue, it's a capacity issue, and also you don't know what providers are available to you. Example, if you have to go through a telecom provider, who are available in that area versus who are available in other area. How are they going to allow you to have the either MPLS, or are you going to go through the BGP? How do you get that, and what kind of switches you have ability on either end of it, which was not pre-thought. So that's why you go with a reference design, a standard reference design, which allows you for best practices that are done in both ends, for not just two, you can have multiple, right? It's not like we are only talking of data center 2, it could be multiple. So therefore, always it is preferable to start with a data center. If you have the, what you call the luxury to start fresh, always make sure go with a reference design.
Yeah.
So I have an experience so far in the past where we built one data center, we ran out of space. We built a second data center in the same building. We very promptly ran out of space within, I think it was 13 months. So we ended up building yet a third larger data center not far away. But when we started building that facility, we had to look at everything from power to our risk profiles to what actually are, as Prakash mentioned, the carriers that were available to get the fiber there. We ended up doing our own fiber in the ground for part of the area just because we had to make it work, to have the bandwidth for our systems. But we ended up having to build this entire profile of all the risks, all the things that we needed. And we had to very methodically work through that list. And even to the point where we were walking around the streets nearby to find the carriers that wouldn't talk to us directly, so we could find out who owns fiber, so we could figure out where to bring in a secondary network connection from. And it's all those things you don't think about until you actually you're on the ground going, oh, I need to figure this one out now too.
Yeah.
That reminds me of one thing. Some 10 years back, I had a data center to migrate in Palo Alto for one of the commercial players. And the problem was they moved from one place to another. The other place, you don't get provisioning. You go to AT&T, apply for it, takes 6 to 8 weeks to get all the stuff. And the lease is running out. So what do I do? So what I had to do was take a wireless provider to over the air and connect it to the data center to enable it for running bare minimum so that they can operate it. And it was one of the biggest challenges I faced. I have run data centers several places, including my own in 90s, starting from zero. It was called something called, what was it? Internet. So it was at that time it was Netcom and other players. So it was easy to get some IPs and here. And when you go to next place, you don't know what IP subnet you are going to get, because if the provider has not provided you, then you are left with only what is available. So IPv6, the ability to route, and then you have to borrow from some neighbor who has got it to run the data center. So situations are very, very dynamic. One cannot predict what you will face when you, especially have a situation where you have got one data center you didn't plan earlier for the second, or any of these migration issues also.
Mm-hmm. That's really interesting. Well, yeah, running over wireless feeds must be really interesting to do that. But I mean, we can't sit here and all admit that we haven't all thought about, doing some really questionable thing to get us through a very specific period of time. And, we all have these stories of having to kind of work around an issue using something that's very not unusual, I would say. The one kind of small, easier topic that I'd like to touch on, and this one is common in every single operation, which is tracking component changes. So it's all nice and dandy when you come in and you have all the MAC addresses and all the perfect serial numbers for everything. And then with times, drives fail, NICs fail, all different things fail and change in the system, and then your initial state is not the state that the server is today. And a lot of times, even sometimes, it's just going to be part of an operational thing where somebody decided that we're going to upgrade the memory on all these boxes to something else, and all of a sudden that's all changed. And so my question is to kind of everyone's sort of conversation is, how do you deal with these changes in an environment, and how do you track those changes? Do you have a long-living asset ID? Do you kind of recycle the asset, as in like it's a brand new asset with a new set of systems that are set up? How do you go about doing that?
I mean, that seems like a number of different questions. I know that at least from a community standpoint with software, there's been some interest out there of being able to re-introspect. We actually add support so that someone could re-introspect a machine that's already been deployed, which I hope someone finds useful. But
I can confirm it's very useful. Use it a lot, actually.
Excellent. That's great news. For this use case?
Roughly speaking, actually, it's often when you reconfigure the RAID and you want the boot hint to be fixed. It's easier just to reinspect it and it gets it right again. But yes, also NIC swaps, same thing.
Yeah. Okay, that's interesting. And then, so John, you're kind of mentioning so the introspection. So assuming, are you relying on like Redfish or like the hardware specific out-of-band introspection?
It's a good question. So I meant to share what we were doing earlier and we moved on, but so I mean, the simple thing is for us, because we work with so many different people, we see a huge spectrum. So a lot of people, we might get a spreadsheet where it says, these are the IPMI addresses you're allowed to touch. Good luck to you. Some customers we work with, and actually that's quite good because usually they fixed it for everything for us, win. Some customers are, okay, so we have to install the Linux for you. So what did you want? But more recently, we've been working with Cambridge on the ground up, and they do a very similar process to what you're saying. We're scanning MAC addresses. They do handheld scanners for MAC addresses. Actually, one of the things I was curious about, which I'll just put on the backlog as a question, is how do you care about finding the broken machine? But let's pause that for a second. But what we tend to do with introspection, or what we tend to do is once you've got it enrolled in Ironic, we just do introspection to use LLDP information to find out where it is, because we don't trust the cabling information. And that LLDP seems useful because that's the way, although we're jumping topics, that's generally we're often using like networking generic switch or something like that to configure the switches. So we need to know the switch MAC and the pork address for Ironic to do the right thing. And LLDP seems the most sane way to get that information. But yeah, we tend to use a lot of introspection. So for the Cambridge case, what we're actually doing is doing iDRAC DHCP based on the MAC addresses from the handheld scanners. So that gives you the host names. All that information, you then just enroll the node in Ironic. And these are actually all Dell servers. So we're using the iDRAC out-of-band information to get the MAC address for the 1 gig PXE. So then we can reconfigure the BIOS to do what we need. Wasn't quite, we did request something, but it wasn't quite right. More because we requested the wrong thing, I think. Anyway, so we just reconfigure the BIOS to do the right thing on that 1 gig PXE NIC. The important thing was the iDRAC came doing DHCP. That's the only thing I really cared about, because that meant we got the IP, which is going back to the previous conversations. But so we actually did out of band inspection to get the first bit of information. Then we did in band inspection to get the rest of the information. Because we just got an awful lot more information from the in band inspection. So to answer your question, kind of both. But that was kind of just a journey. In this particular case, we were using like Mellanox ConnectX-6 NICs that didn't come with Ethernet enabled by default. So we had to do everything on the 1 gig to move on to the high-speed network. But it was a bit of a journey. But yeah, I think both have proved interesting in their own right. I kind of like how the out-of-band means that kind of you don't need to be able to pixie boot to get the information. But on the other hand, in-band is great because you can kind of run arbitrary code inside your inspection image to collect whatever you need to collect.
Yeah.
So yeah, I think it's been quite a useful tool all over the place.
Well, I was also kind of trying to point out that we added the ability for, if you have it running OS on a machine, you can say, you can install the command and actually directly go, I need to supply update information to inspection right now.
Oh, okay. Oh, I was thinking about reinspect via the API. Okay.
Oh, no, well, there's that too, but.
That's what I was thinking. Okay.
Cool. The idea was, oh, I've had to recable half the server because the requirements changed or whatever. These things do happen in physical data centers. And I need to update that networking information, or I added hard disks, or I removed hard disks. And while it is a running instance, I've made a fundamental change to the machine, and I need to somehow supply that information and not really interrupt the running workload. It's not exactly a cloudy thing, but it's still a case that you still have to support when you have bare metal machines out there.
No, that's interesting. Actually, yeah, that's going to be much more interesting on hypervisors, actually, thinking about that. I think generally I quite like using introspection as in via the API as a way of just resetting the state of the box, because you go back to manageable, do inspection, and kind of recycle the box as if it was coming in fresh. But yeah, that's a different case.
Yeah, the nice thing about like doing like introspection on an active instance where the user is on and using it for something, it's like you can like track any changes that Julia said. So for instance, if something is replaced, and you would afterwards, like a couple of months later, you want to know which firmware version is running on which hosts. If you have to like replace the firmware version and you have up-to-date information, this active introspection introspection active nodes is actually quite an interesting thing to have.
So
I think I'd always assumed that you would deprovision the machine before doing that kind of thing. But yeah, it's good to know.
Yeah, I could see that our users would even want to do stuff like with an active node, they would actually want to have it basically go through and if possible, run through some automated process to update firmware for them in some cases without deleting their instance.
Exactly, that's the point. I mean, if we would ask like all our users, okay, we have to update the firmware, you have to delete all your instances, give the nodes back to us, we update the firmware, and then you get your nodes back, that wouldn't go down very well.
It's exactly the same for us. Our users are addicted to their running instances. They can't give them up.
Well, which also brings.
So you've been using. Sorry, go ahead, Arnie.
This also brings up the other issue. Of course, if you say like, if you hand out, at least in our case, if you hand out a physical node to a user, the user thinks that he owns the machine, right? If you have like active introspection, you need to have something on the user's instance that's actually actively monitoring it inside. So you can probably only do this if you have some kind of policy where you say like, look, you can have an instance, but you only run with these images, or you have to install this container in order to like keep us up to date of what's going on the machine.
Yeah,
we haven't tried this yet to like push this out on many users, but we had this before, where we basically, so when our machines were installed or are installed with Puppet, we have some kind of base modules that also include some sensors that would collect this data and just send it into our CMDB or DCIM system.
Yeah.
I'm curious, so when you get users to update, oh, sorry, go ahead.
No, go ahead, John.
I was going to say, like, when you get users to update the firmware in place, are you providing, like, please run this script on this OS to do this thing?
No, it's not like we ask the user to update the firmware. The example I had was more to, like, understand For instance, if you have,
Okay.
I don't know, a delivery that's like 2 years old, and then all of a sudden there's an issue with the hard drive firmware, and meanwhile you have replaced disks left and right, and you don't know which firmware level is where, and you can then identify, okay, I have to like attack only these subset of machines rather than all of them, because I know that like on so and so many the disks have been replaced meanwhile. But we don't ask our users to update firmware.
That's yeah, that would be really handy, because one of the things we've actually done is because even a lot of our users can't even stand to kind of reboot the hardware. So I still want us to get that active reinspection, because I think that would be hugely useful for us. What also I think but what we also still have to do, because of users that don't even want to reboot, for us to find out what firmware they're running, we work with our security team who has some scanning tools that run on our production servers. And that's just part of the data center policy, right? If you run the data center, then our security team needs to have access to at least run this sort of scanning infrastructure that uses signed, like sort of GPG signed pre-authorized commands that it could, like, it'll SSH in and run that. And so we've worked with them to do things like scan all the machines in the company and find out which ones have this known bad firmware, for example, that don't work with certain versions of RHEL. And then that way we're able to target those machines, mark them as being in maintenance mode, reach out to the properties that are consuming them, and let them know, like, hey, if you try and reimage this to like this newer version of RHEL, by the way, it's not going to work.
Right.
And you don't all trust the out-of-band information, I guess, because there's too many out-of-band types to talk to, or?
That one we had to do entirely in band. That we actually literally had to literally SSH in and just run some inspection commands.
Okay,
So,
it just wasn't possible out of band in that case.
Oh yeah.
Is this something where something like OS Query, if anyone's familiar with that, could kind of be interesting for something like this?
We used OS Query for a while and then we stopped. I think there were some performance problems with it because it would gather this huge pile of data, then ship it off. And we definitely were using it for a while, because I used it for a project like this in the past where I used like all the OS Query information from the company was shipped off into Hive. And then I used Hive to do some queries to extract some data from it. But we had to stop using it because of all the performance problems it was causing. And by that, I mean, by and large, most of our application owners are, they're not using, if they're using bare metal, they're really not using the machine to its full potential. Like we have a lot of idle CPU cycles, but some other properties at the far end of the coin where they like push the machine to like 99% of what it can do. And even our configuration management system running slightly too often was actually causing their QPS to drop. So it was like an interesting two ends of the spectrum there. So I think that was one of the reasons why we actually stopped using OS Query.
Mm-hmm.
I mean, the beauty of using like or redoing introspection while the instance is live is that you collect the exact same data in the exact same format, and you can send it to the exact same backend, right? So rather than having something like when the node comes in, when the new servers come in the very beginning, you collect one set of data. I don't know how many CPUs do we have, what is the firmware version of the disk and so on. And then later on you do something else. You have actually the same code doing the same things, and you just update your DCIM.
Yeah. And so just we're talking a lot about very maybe ironic specific terms, and I wanted to call out if there's any other users of different bare metal orchestration platforms like MOS or I think Digital Rebar, or there's Tinkerbell. Anyone's kind of using those and can maybe talk a little bit about the idea of kind of having an updated information or profile about the systems as they're running.
Okay.
So
this is Rob Hirschfeld. I can talk to Rebar if you want.
Go ahead.
Sure, and then we can have Rain share some stuff after. Cool.
Sure. I'll give you camera too. Hey, so this is Rob Hirschfeld. Y'all, I've been in the community for a while, but not active lately. And so we've been doing digital rebar for a long time, and it as a primary workflow will start within memory. So our primary is not reliant on out of band, it relies on a Pixie in-memory agent model. And so we have developed what's gotten to be a very comprehensive hardware inventory scan process. It's not invasive, and so we will run that as part of any boot process workflow. That'll collect pretty much as much information as we can possibly get. LLDP we did as a secondary thing because that's not always turned on, so it's an additional workflow step. And it takes time. The overhead of collecting the data is pretty small, but then that gets stored back automatically in the data set. And then we have additional downstream workflows that it's a huge JSON blob. It's actually probably the biggest single piece of data in the system. So we flatten it. So we have a secondary system that'll then scrub that into smaller, it flattens it. And then the nice thing about flattening it is that then you can search individual items that you want out of that item for secondary consumption. So if you then want to search by manufacturer, number NICs, RAM, whatever, you can't, it's hard to search into a JSON blob, but you can then add those as searchable items. And then one of the things that we added once we had that data was then you can, it tracks the last version of that and it will do comparisons. And so if you want, it'll warn you that there's issues, it'll stop if there's issues. Boy, and then we collect there are all sorts of other information collects on the machines in an ad hoc way. So any information that you wanted to collect, we include, and then you can make those either downstream, force them into downstream systems, feed them to a data collection CMDB type system. You can feed them into other inputs and profiles. So like we have Ansible scripts that you can kick off, and then we'll insert the relevant data from the inventory into the Ansible scripts, either running on the machine or from the server. Same thing with Terraform from that perspective. And then, but we have as a process, while we do out-of-band management for all the different vendors, using whatever vendor out-of-band management stuff, we don't rely on out-of-band management. So we can do things like boot a Raspberry Pi. And we found that to be really useful. While it's useful to have out-of-band management, there were some other use cases where that didn't work so well. Well, like it wasn't set on first boot or something like that, which is very common.
Mm-hmm. Cool.
That's it's hard to condense all that stuff into a single thing. So I'd be open to questions.
I think there was a question from Arcady asking if boot image, there's a required boot image support for embed introspection.
For what type of machine?
I'm not sure, Arcady, you want to chime in?
I see it.
Yeah, it's for generically when you try to introspect the hardware, if you do it in band or out of band, and it does require the boot image support ahead of time?
That's a good question. No, none of the agent work we do is image specific. So the way, since we use Golang as the image source, it's multi-arch and multi-OS. So we have the exact same tasks running on any OS for the system. So when we do discovery, it's the exact same code, which is really handy. So if you want to do work, you build a workflow that works in the discovery image, which is based on CentOS. It'll work just fine in any Linux. And most of the stuff is cross OS, so it'll work on Windows also. ESX is its own weird beast, but ESX or RPi or Mac. Not that many people are automating Macs.
Mm-hmm.
We do for a test, but not much more than that. And then we can, there's a feature that we added that allows you to move the agent out of the machine and back to the server. And then so you can run, if you have an out-of-band task, or if you have to connect to say a switch or another external system, you can transfer the agent dynamically into a container running on the endpoint, which is the server. Server gets really overloaded. And that would then let you do, if you needed to do something esoteric from an out-of-band management perspective, you could move the agent to the server, pull in whatever data you needed from the system, and then take those actions against it. We've been doing that more and more. We have a whole bunch of server-side control points for out-of-band management. And some of them, like when the machines are not on, changing boot order, which is really important, as y'all know. We used to do that as a sort of a dedicated process, but once we did the context switch to the server, it became easier to just run. Basically, the agent is always alive, even if the server's off.
Yeah, cool. As we're kind of getting closer on time, I would love to hear some comments from Rain, because I think there's a different perspective where, you know, you can't run much in the system, unlike, you know, some other examples where you can run something in the system. And that's kind of in the case, I guess, of Tinkerbell, because it comes out of Packet, and that's more of a provider-based thing. So love to hear about that.
Right. So Packet was founded 5 years or so ago. I will caveat this with, hey, I'm Rain, and I was with OpenStack for a while, for 5 years or so. But I played a lot more with OOO and Packstack and RDO, and not so much with Ironic, sadly, even though Julia and I would hang out a lot. So I'm very new to this bare metal stuff. I've never done ops or sysadmin work or anything like that. But one of the reasons that Packet is excited about me is for the DevRel side and for my open source experience. And that's what they've recently done, is taken a piece of the functionality that they use to provision their hardware, which instead of renting out virtual systems, you can rent out straight bare metal, and you get a dedicated machine and whatnot, and it's super fast, So they're starting to take pieces of that functionality and make them open source. And the first one that they made open source is Tinkerbell. It's a baby open source project. Mara is online with me today, and she's going to correct me if I'm wrong with anything, but basically it's bare metal automation. So it detects the system and then spins it up for you, and you can use it for monitoring, but that's not its real primary purpose. Its aim is to give you the system with whatever operating system you want ASAP. It's 5 minutes to dopamine, 10 minutes to dopamine, something like that. So yeah, I'm listening to all these questions, and I'm absolutely fascinated by the different experiences, because over here, we're trying to provide that hardware as if it were software. So at that speed, and honestly, the ops people are the magicians for me. I'm just fascinated by all these decisions. I do know it's fully automated. I just don't know how, which I guess is the dream for automation. You want to be able to have someone click and it just magically appears.
Definitely agree with that.
Yeah, that's what we're all. That's why we're here. We're trying to get the parts that haven't clicked yet.
Correct, but I want to point out there is two different angles to look at that. So one angle is the tool set needed for that, but the question is, how is that delivered? Is it delivered as kind of self-type service, as a service, or as more kind of a product or integrated into the thing? Because if you are going to the service, then you have to worry about all sorts of other stuff, the security, identity management, and all of the other
networking,
to ensure
storage.
correct, to
Yeah.
ensure that you have all the right access to the right things, versus if it's part of the kind of integrated administrative domain, then it's a much lighter, it's a very different delivery vehicle.
Yeah, it's more towards the latter, because we want to stay away from, we want to specialize in hardware delivery. So we've specifically stayed away from, for example, storage. We've stayed away from networking. We're trying to stay and specialize on layer 0. Mara might have more input on this than I do. Or not.
Yeah, unfortunately, I think we're getting close to our time. I think our break is in 1 minute exactly. So I want to thank everyone for actually participating in this conversation. It was really nice and really helpful. We got to hear a lot of different stories from a lot of different scale. I wanted to individually thank all the folks that participated for this first half. To kind of end it on a very bad joke that maybe some people will get the reference. But someone asked us, how do you, I think it was John asked of how do you find the machine? And that reminds me of like a very old IRC quote that was like QDB, which is like, I've lost a machine literally. In response to ping, it worked completely. I just can't figure out where in my apartment it is. And I do feel like sometimes maybe we deal with that in our systems. But yeah, thanks everyone. We're gonna go on a short 10-minute break and then we're gonna go back for the next half. That's gonna be moderated by James.
Thanks, Al. See you in a few minutes.
Okay, see you.
Thanks, Mohammed. Yeah, so we will take a short break and we will see everybody back here for the next part of our hardware provisioning lifecycle for bare metal discussion, part 2, in about 10 minutes. So see you all then.
Thanks, Ashley.
I like the whole music. Thank you.